Hello everyone. In the last video we looked at how we can add complex numbers on an argand diagram, and we had our example, which is z1 is equal to 2 plus 3i and z2 is equal to 4 minus 2i. Yes, and they wanted us to represent z1 plus z2 on the argand diagram, and Roman 2 they wanted us to represent z1 minus z2, and Roman 3 they wanted us to represent z2 minus z1. Is that okay? So we are going to sketch on the argand diagram. Good. That is our argand diagram. This is real of z, and this is the im of z. Is that okay? And remember, our z1 is equal to 2 plus 3i, and our z2 is equal to 4 minus 2i. So we can say that this is our 1, this is our 2, this is our 3, this is our 4. It's not on sketch, but we have to bear with it. This is negative 1, negative 2, negative 3, negative 4 going. Now we have our z1, it's 2 plus 3i. Our z1 is 2 plus 3i, so this is 2 and 3i, so that is our z1. And our z2 is 4. Our z2 is 4 minus 2i. This is our 4 and our 2i. So this is our z2. Remember, they want us to get z1 plus z2. So when we are adding complex numbers, we add real to real, which is a 6, and imaginary to imaginary. So we have 3i minus 2i, which is I. Is that okay? This is 5, this is 6. Now we are having on a real plane, which is a 6, and on the imaginary plane we have it as 1. So we shall plot our z3, which is the resultant z3, and it is just a formation of z1 plus z2. Let me hope we've understood that argand. So let us go to another one. They want us to plot z1 minus z2. Is that okay? z1 minus z2. So we have our argand diagram. That is our argand diagram. We have to label the axis, real of z and im of z. 1, 2, 3, 4, 5, 6, 7. You must be accurate while sketching these graphs, because we may ask you to obtain the angle between the complex numbers. So you must be accurate while sketching yours. Mine is not on scale, that's why you see me just writing my own things, but you have to plot yours when it is accurate. Our z1, we say that it is 2 plus 3i. Yes, on the real our z1 it is 2 plus 3i. So on the real part we have a 2, on the imaginary part we have a 3. Yes, and it shall be like that. So that is our Z1, and our Z2 is 4 and then a minus 2i, 4 minus 2i somewhere there. So that is our Z2. Remember they wanted us to find Z1 minus Z2. So Z1 minus Z2, it will be, we are going to subtract real parts from real parts and imaginary parts from imaginary parts. That is 2 plus 3i is Z1 minus 4 minus 2i. So now 2 minus negative 2 minus 4, that is a negative 2. 3 minus minus 2i, that is a 5i. Therefore we shall have a negative 2 somewhere here and a 5i, so we shall get our complex number in the second quadrant. So this is Z1 plus or minus Z2. Good. So now the last thing is they wanted us to find Z2. They wanted us to find Z2 minus Z1. So Z2 minus Z1, and Z2 we say that it is 4 minus 2i. So we are going to subtract Z1, which is 2 plus 3i. So 4 minus 2, that is 2, negative 2i minus 3i, which is a negative 5i. So we shall represent it on our argand diagram like that. We shall have 1, 2, 3, 4, 5, 6, 7. So that is the real axis, and this is the imaginary axis. So we have 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Here we have 1, 2, and 3. 1, 2, 3. So we want us to first plot Z1, whereby Z1 is 2. Our Z1 is 2 plus 3i. It is 2 plus 3i, which is this Z1, and our Z2 is 4 and negative 2i. 4 and negative 2i, which is here, and we shall plot it like that. So this is Z2. Now we wanted to find Z2 minus Z1. After doing that, we obtained our Z2, which is Z2 minus Z1, which is the resultant is a 2 minus 5i. So it is a 2 on the real axis and minus 5i on the imaginary axis. So upon sketching, we shall have a combination of Z1, Z2 minus Z1. So this one will tell us that our complex number, which is the resultant, lies under the fourth quadrant. So what do we get from there? Z2 minus Z1 is not equal to, I said Z2 minus Z1 is not equal to Z1 minus Z2 because they lie in different quadrants. Is that okay?